43. Finite mathematics. In the previous lecture, we learned how to calculate basic probabilities using sample spaces, equally likely outcomes, and relative frequencies. Today, we are going to build on that foundation by learning several important rules of probability. These rules will help us solve problems involving events joined by or overlapping events, mutually exclusive events, and complements such as not or at least one. These ideas are very important because they appear frequently in probability problems and on exams. So, by the end of today's lecture, you should be able to use the basic bounds of probability, use the fact that the probability of the sample space is 1, apply the addition rule for mutually exclusive events, apply the general addition rule for overlapping events, use the complement rule, and decide which probability rule is appropriate for a given problem. Okay, let's begin with the basic properties of the probability. So, property 1, bounds on probability. That means for any event E, for any event E, probability must be between 0 and 1 inclusive. Probability must be between 0 and 1 inclusive. If probability of event E equals 0, the event is impossible. If the probability of event E equals 1, the event is certain event. If the probability lies between 0 and 1, the event is possible but not guaranteed. Okay, let's quick check. So, could a probability equal 1.25? No, because the probability always between 0 and 1 inclusive. Second, could it equal negative 0.3? No, again probability cannot be negative. Lastly, could it equal 0.27? Yes, it could be because the probability always between 0 and 1 inclusive. Let's go for the property 2. Probability of the sample space. The entire sample space contains every possible outcomes. Therefore, probability of sample space equals 1. So something in the sample space must happen. Property 2. So let's see the example. Suppose the sample space W, X, Y, Z with probability of W equals 0.25, probability of X equals 0.05, probability of Y equals 0.38. Then find probability of Z. So since all probabilities must add to 1, since all probabilities must add to 1, we write probability of W plus probability of X plus probability of Y plus probability of Z equals 1. So substitute in values 0.25, 0.05 plus 0.38 plus we don't know, probability of C equals 1. Then 0.68 plus probability of Z equals 1. Probability of Z equals 1 minus 0.68. Probability of Z equals 0.32. Whenever one simple event probability is missing, subtract the known probabilities from 1 to get that unknown probability. Okay, next, mutually exclusive events. Mutually exclusive events. So now let's talk about events connected by the word O. Recall from the section 7.1. that two events are mutually exclusive if they cannot occur at the same time. That means let's say E and F. Let's say E and F. E intersection event F equals empty. So they cannot occur at the same time. If two events are mutually exclusive, the probability that EOF occurs is simply we say probability of E union F. If two events are mutually exclusive, the probability that EOF or E union F occur is simply probability of E union F, probability of E plus probability of F, because the intersection part is empty. Let's see the example. A fair six-sided die is rolled. Let event E, rolling number 2, event F, rolling number 5. Then these are mutually exclusive because one roll cannot be both 2 and 5. Therefore, we know that probability of event E 1 over 6, probability of event F 1 over 6, probability of therefore probability of event E union B, EOF, 1 over 6 plus 1 over 6, 2 over 6, 1/3. 1/3. Okay, we can extend this formula if several events are all mutually exclusive. If several events are all mutually exclusive, we can simply add their probabilities. For example, on a die, probability of getting 1 or 3 or 5. Probability of 1 union 3 union 5. 1 over 6 plus 1 over 6 plus 1 over 6. 3 over 6, 1/2. 1/2. Right? Okay. Then what happened if the two events are overlap? That means if the two events have the common outcomes. So recall the general addition rule as we discussed in the set notations. Now we are going to discuss it for the probability events. General addition rule. Probability of A union B equals probability of A plus probability of B minus probability of A intersection B. So we subtract the intersection because it was counted once in probability of A and again in probability of B as usual, as same as in the set notations we discussed in chapter 6. So let's see the example. We use this general addition rule with if two events can overlap. Two events with overlap. Example. A fair die is rolled. Then let event A roll in an even number. Roll in an even number. Event B rolling a number greater than 3. Rolling a number greater than 3. Then first, probability of A 3 over 6 1/2. Probability of B again 3 over 6 1/2. Then what about the intersection? A intersection B, we have 4 and 6. 4 and 6, the probability of A intersection B, 2 over 6, 1 third, 1/3. Then probability of A union B by the general addition rule, probability of A plus probability of B minus probability of A intersection B. Substitute the values 1/2 plus 1/2 minus 1/3. 2/3. So let's verify this union directly. List the union. A union B, 2, 4, 5, 6. There are 4 favorable outcomes out of 6. Probability of A union B, 4 over 6, that means 2/3. So our answer is correct. Our answer is correct. So let's see the important comparison with the general addition rule and the addition rule. That means mutually exclusive and events with the overlap. Important. If events are mutually exclusive, probability of A union B equals probability of A plus probability of B. If events overlap, probability of A union B equals probability of A plus probability of B minus probability of A intersection B. Okay, then the last rule, the complement rule. The complement rule, as we discussed for the sets, the complement rule is often the easiest way to solve probability problems, right? The complement rule. For event E, probability of E equals 1 minus probability of E complement. Equivalently, probability of E complement equals 1 minus probability of E. Here, E complement means the event that E does not occur. Right? So let's see the example quickly. Let the probability of selecting a red rose, let the probability of selecting a red rose is 0.35. Find the probability of not selecting a red rose. Find the probability of not selecting a red rose. So easily use the complement rule. The probability of not selecting a red rose could be 1 minus probability of selecting a red rose. So 1 minus 0.35, 0.65, 0.65. So let's see one more example. Example, let E be rolling a number greater than 4, rolling a die. Let E be rolling a number greater than 4. Then event E could be 5, 6. Directly, probability of E, 2 out of 6, 1/3. Then E complement, 1, 2, 3, 4. Therefore, probability of E complement 4 over 6, 2/3. Let's see the complementation rule. Probability of E equals 1 minus 2 over 3, 1/3. Both methods gives the same answer. So, when is the complement rule especially useful? So, look for phrases like not, none, at least one, one or more. For at least one, it is often easier to calculate 1 minus probability of none. Right? Okay, let's see the example. A family with 3 children. Suppose a family has 3 children. Suppose a family has 3 children. Assume each child is equally likely to be a boy or girl. Assume each child is equally likely to be a boy or girl. That means the first step, write down the sample space. Using B for boy and G for girl, the sample space could be 3 boys, BBG, BGB, BGG, GBB, GBG, GGB and GGG. You can use the tree diagram. There are 8 possible outcomes or equally likely outcomes. Okay, so for an example, you can draw the first one, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, and boy, girl. You can see the tree diagram to get the all possible outcomes. Then next, find the probability of all boys. Probability of all boys. So only one outcome here. B, B, B. Therefore, probability of all boys equals 1 over 8. 1 over 8. Then what about the probability of at least 2 girls? probability of at least 2 girls. So the favorable outcomes are BGG, GBG, GGB and GGG. So you can see that BGG, GBG, GGB and GGG. At least 2 girls. So there are 4 outcomes. So the probability at least 2 girls equals 4 out of 8, 1 half. 1 half. Okay. I hope everything clear so far. You can try the exercises by yourself. So please make sure to try those exercises before the exams. And what are the common mistakes? So the common mistakes are adding probabilities without checking whether the events overlap. Forgetting to subtract the intersection in the general addition rule could be the most common mistake. And subtracting the intersection when the events are already mutually exclusive. Confusing with the union and the intersection wording O and forgetting that the complement plus the original event must equal 1. Listing only some outcomes in and at least problems. Failing to recognize when the complement method is easier. Okay. So here's the quick decision guide for the exams. Exam strategies. Here's if the problem says O. If the problem says O, are the events mutually exclusive? Ask yourself, are the events mutually exclusive? If yes, add. If no, add and subtract the overlap. If the problem says not, or none, or at least 1, consider using the complement rule. Consider using the complement rule. I hope this is helpful. Okay, let's summarize today's lecture. We learned several fundamental rules of probability. Every probability must lie between 0 and 1 inclusive. The entire sample space has probability 1. For mutually exclusive events, we simply add probabilities. For overlapping events, we use the general addition rule and subtract the intersection. Finally, we learned the complement rule, which allows us to calculate the probability of an event by subtracting the probability of its complement from 1. The key skill is not simply memorizing formulas. You must first recognize the relationship between the events and then choose the correct rule. Thank you for watching, and I'll see you in the next lecture.